Ladies and gentlemen, today I'd like to bring up quite a serious topic: caching and storage strategies for your Lightning components to make them run faster. I know you have a comprehensive knowledge about a backend optimization, Apex, Cacheable jobs here, there, which is fine. But more and more often I come across people who just don't know how to optimize the front end. And very often it is the front end that is the problem. You know, when you just sit there watching the spinner and thinking, what the fuck? But let's talk about the causes and solutions. The most common reasons are fetching the same, rarely changing data over and over again, no pagination, trying to load thousands of records at once, Lightning components holding massive arrays or objects in memory, and memory leaks, when variables never get cleaned up. You don't have references to those variables anymore, but they still live inside the browser. And there are actually many other reasons, and if you think about it, it all comes down to how you organize the caching and memory of your Lightning components. And really by Lightning components I mean the browser, because if everything is clear with the database, Salesforce database, then the browser is the collection of different storages intended for different tasks, and which you most likely don't even use. So let's fix that. Well, of the easiest to have local storage and session storage, which you can access by calling the session storage or local storage variables in your JavaScript code. They have two main publicly available functions: setItem and getItem. For setItem you pass a key and a value, both of them must be of a type string, so if you want to store an array of data as a value, you first need to serialize it using JSON stringify. And to retrieve it by calling getItem, you simply pass the key that you specified when setting the value. These two storages can store data up to 10 MB depending on the browser, and their significant difference is that session storage is a temporary storage, meaning that all the values you store there will be deleted as soon as you close your tab, although it will survive a page reload. Local storage is a persistent storage, meaning you can write a value there and it will be saved even when you close the tab or restart the machine. Next you have IndexedDB. It is a so-called database in your browser that can store complex data, even files, and its capacity is already measured in hundreds of MB. It is a great choice if you have a large set of records that are actively searched, sorted and filtered. For such cases, IndexedDB even provides indexes and cursor to make it work fast. It is also an ideal choice for those applications that require work in offline mode, because you always have that database in your browser that you can get access to. And last but not least, I would like to mention Platform Cache. This is not exactly a browser storage, but a temporary server-side cache in Salesforce, which allows you to store complex data sets, and usually it is a really good way to reduce the number of so-called queries, and it is really fast. For example, here's a small change to the method where you first check if the value already exists in the cache. This check can significantly increase the performance of your application, because even the lightest so-called query to the database is not comparable to retrieving this data from the cache. The performance is hundreds of times better. And it might seem like these storages, other than Platform Cache, aren't something that we can leverage from as a Salesforce developers, for various reasons, but primarily because of Lightning Locker and Lightning Web Security. That's the first thing that comes to mind. But that's actually not true, especially if you have Lightning Web Security enabled. Their usage is completely possible. Moreover, when used correctly, it becomes an incredibly powerful tool to improve performance of your application. So let's see in practice how all this stuff works. Let's talk first about a standard Salesforce caching using Apex methods marked as cacheable true. For example, we take our Find a Guilty application, where user specifies the record type and various filters to select exactly the records he needs. When saving, I show him a preview of these records in a model window. If we look at the code, we will see that in the Lightning Web component, I call the getFilteredRecords for data table method in the wire adapter. Well, first of all, we use this adapter when we want these variables right here to react to a change. That is, if my review process ID parameter changes, this adapter will take care of getting new data with a new value, without any effort on my end. But in this case, this reactive behavior is not as important to us as caching the result of this call, since the main idea of this wire adapter is to cache the value. And this is clearly visible if you go to the controller. This method is marked as cacheable true, which means that this data is received once when the component is opened for the first time, and on subsequent openings, this method will not be called, but the value will be taken from the LDS cache. This diagram describes this movement quite clearly. That being said, our problem in this case is that the user can actively change the values of these filters to get what he needs. In fact, the whole point of this structure right here is to actively change the values. In this case, this creates a problem that if user makes changes and opens this model window again, it will show the previous cached value. And we can definitely fix it. All you need is to import the refresh apex function somewhere at the top in your Lightning Web component, and then in the wire adapter itself inside, use this method to update its result, meaning to force this apex method to be called no matter what. But in this case, what's the point of this caching? That is, even though I use caching, I destroy it by forcing this method to be recalled. With this approach, I literally destroy all performance advantages of caching in Salesforce. That's why this approach cannot work here. We need something smarter than just a standard Salesforce caching that we have no control over. And this smarter thing could be our custom caching. Just take any browser storage, add a few handlers that will determine whether the filters have changed or not. If not, display the cached value, otherwise retrieve a new one. Initially, we need to decide on the main storage, local storage or session storage. Both of them will survive the page reload, but in general, when it comes to caching data that is actively changing, I recommend choosing session storage. In local storage, I would store something like the user's language, which does not change very often and which will be stored for a very long time. Therefore, let's take the session storage. And in our case, it should store the data that looks like this: columns for the data table, records, and total count. And as for the key name, you decide totally for yourself. There are no clear restrictions or naming conventions on this, up to you. But the problem here is that the number of records can be measured in thousands, and session storage cannot store such large amounts of data. Generally, it's a bad practice to store more than 5 records, I would say. And here, IndexedDB comes to the rescue. As I said before, this is a database in your browser and it can store very large amounts of data. This is exactly what we need in this case. To use IndexedDB, make sure that you have the Lightning Web Security enabled in your Salesforce, and then you can access it by simply calling the IndexedDB global variable in your JavaScript code. Here's an example of the code to open this database. You use the public function open, where you pass the name of your database. This name is again custom, meaning you come up with a name for it yourself. Then you take care of 3 possible events. On success, this is when the database with the name you specified already exists. Then you simply return its reference back. On error, when something went wrong and it was not possible to open or create this database. On upgrade needed, when this database with the name right here does not exist and it's being created for the first time. In this case, you will also need to create an object store when your data will be stored. Think of it as a table in your relational database, but in this case, it can store your values in any format you want. You are not limited to following any strict rules. Also here you can create indexes to make searching in this database faster. Also cool thing. Now that we have the index database, let's also take care of our session storage. Everything is much easier right here. One function will be responsible for storing the values. As I mentioned, the key is completely made up, and values in our case are the filters that are specified in the component. To get it, we simply use window.sessionStorage.item and pass in the key that we used earlier. For the first time when user opens the model window, we store the current filters on the component in the session storage, create an index database, and write the values of our columns and records into this browser database. The function for doing so will look like this. On the next page opening, let's just reload a page, we check if these new filters right here match the ones we saved earlier in the session storage. If so, we simply get the existing data from our index database. And if not, we call the Apex controller method and write the new data to the database and the new filters to the session storage. And you also need to add expiration date into this logic. After that, I don't see anything that's stopping me from calling it a cache as it can be. But what problem does this approach have? Pagination? No. It's completely possible using the index database. There is a cursor, yeah, there is even such a thing, so it's actually easy. The problem in my specific case is that I assume that the number of records might be more than 50,000, which will cause the Apex controller method to fail because of the limitations. So what do you think the approach could be right here? You can stop the video, you can think for yourself, come back, and the best way from my standpoint would be to use platform cache and the recently introduced feature called Apex Cursor. In order to create a platform cache, we need to go to the platform cache in the Set tab and create a new partition. And here we specify how much memory we want to allocate for org and session storage. The difference between them is very similar to local storage and session storage in the browser. A session platform cache is a temporary storage that lasts only for the duration of the user's active session, and the org platform cache is shared across all users in the org and can retain values up to 24 hours. Now, in Apex code, to store a value in that platform cache, you first need to specify the cache type, be it session or org. Then you use the method put, where the first value should be in the format: first the name of your namespace, by default will be local, then the name of your partitions that you just created, and then your custom made up name. And to get it, we use the get method with the same key syntax. In our specific case, we use a session platform cache where as a value we store the columns of our data table, and instead of a list of records, we store a serialized Apex cursor, which is actually represented just as a single ID. Again, storing large amounts of data in this platform cache is a bad idea, but our approach works well here, it's just an idea. But wait, what is an Apex cursor? An Apex cursor is a recently introduced new way of getting large amounts of data, up to 50 mil, where you specify your SQL query and get a cursor in response. After that, in chunks, you get records from that cursor. Its key advantage is that it allows you to implement literally eternal pagination, meaning it does not have the limitations as SQL offset does, where the maximum offset is 2000 records, but cursor allows you to get as many records as you want. This is what we do for our model windows. If it is opened for the first time, we get that cursor and store it in the platform cache, after which we get the first 200 records. If the user scrolls down and we have lazy loading enabled, we call our Apex controller method again, and we no longer get a new cursor, but we use the existing one that is stored in the platform cache, only in this case we get records from 200 to 400, and so on. This logic is also the same if we reload a page and open this model window again. Our cursor is stored in the platform cache right now, so we just get it from there again and pull the first 200 records. Here, the key to your good performance is to determine how many total records your cursor returned. I store it in the total count variable, and the value for this variable I get by calling the cursor method getNumRecords, which returns the total number of all records. As soon as the user scrolls to the bottom, I check if the current number of records is equal to the total number of records, and if so, then the Apex controller method should not be called anymore, since all the data has already been successfully loaded. One more thing is that I could save that Apex cursor not in the platform cache, but in the browser. That is, return it back to the browser and store it somewhere in the session storage. In this case, I probably wouldn't even need to have platform cache at all, because everything will be handled on the client side and I'll be passing that ID back and forth to get the data. It could be, but why I didn't do so? Because it's not really about a performance anymore, but it's about security. If you have a chance to not show to the browser some sort of data, you better do so. That's what I did here. It's better to have platform cache, it's still reliable, it's still fast, but it is secure as well. I'll leave all the links in the description with all code references. You do not forget to subscribe to the channel, leave the comment, like, and I'll see you anytime soon.